everyone. So our today's Leetcode education is 3651, that is minimum cost path with teleportation. So in this we are given a 2D integer array grid and an integer k, and we have to start from the top left cell, that is 0 comma 0. we have to start from our top left cell, that is comma 0 0 comma 0, and we have to go to the bottom of cell, and we have to find the minimum cost to go from this cell to this cell, and we are given k, so that k denotes the total number of teleportations we can do. So there are two types of moves allowed. From any cell we can either go to the right cell or to the down cell, and the cost of these movements are the value of the cell to which we go. Suppose if we go from 1 to 3, so the cost will be 3. And if we go from this cell to this cell, the cost will be 2. And the other movement that we can do is we can teleport to another cell. So suppose right now we are at 5. So we can teleport to all those cells whose value are less than or equal to 5. So see here, all the cells have value less than or equal to 5, and the cost of this teleportation is 0. Suppose if I want to go from this to this, so I can teleport in cost 0, right? So these are the two types of movements that we are allowed, and we have to return the minimum cost to go from the cell 0 comma 0 to m minus 1 comma n minus 1. So let's see the constraints. So the number of rows and columns can be up to 80, and the value of any element can be up to 10 k power 4, and the number of teleportations allowed is are 10. So what is our approach? So what we do is we'll be using a reverse dp, and we'll be using layers for solving teleportations. What that means is, so we'll start from a solution assuming that there is no teleportation, and then using that solution we will be calculating for teleportation equal to 1, and so on. Like we will be using the previous value to compute the next value. So next thing is what reverse dp means. So here we have to go from 0 comma 0 to the final cell. So what we do is we'll be solving it from the final cell to the 0 comma 0 cell. So see, if we start from here and start solving, so what we have to reach here, so our value will be 0 for this cell. Now next cell is this one. So what is the possible operations? Either we can go to right, go to down, or the third operation is we can teleport. But right now we are solving assuming that there is no teleportation, so there is no down operation, so we can go to right. So what is the cost to go to right from this cell to this cell? So it will be 5, right? So we store 5. Next is this cell. So from this we can either go to right or to down. So the value from going to from this cell to this cell is 3, and then from going from this cell to the final element that we have already stored, that is 5. So 5 plus 3, 8, right? Next we solve for this element. So for this element we can either go to right, but there is no right element, so we can go to down. So for going for down, the value is 5. Next we come to this. So two operations, again right and down. So if we'll go to right, so cost of going from this cell to this cell is 4, and from this cell to final cell is 5. So 5 plus 4 is 9. But if we'll go to down, so here the cost is 3, and from this cell to the final cell, that is 5. So 5 plus 3 is, so we will take minimum, so we store 8. So this way we will be calculating for all the cells and store. Next thing is like, so this was without teleportation. Next thing is like how we will be handling the teleportation. So the basic condition for the teleportation that they have mentioned is that we can move from a cell I comma 0 to a cell x comma y if and only if the value at x comma y is less than equal to value at I comma j. And suppose value at I comma j is equal to v. So if value at I comma j is equal to v, that means we can teleport to all those cells whose values are less than equal to v, right? And now, to which cell should we teleport? So we should teleport to that cell whose value is less than equal to V and whose distance to the final cell is minimum. I'll repeating it once again. So from a cell I comma j whose value is V, we can teleport to all those cells whose value is less than equal to V, but we will teleport to that cell whose value is less than equal to V and whose distance to the final cell is minimum of all those cells whose value is less than equal to V. I hope you get it. So what we can do is we can use a vector you to store what this vector will store. It will store minimum cost to move to final cell for every value, right? So if I'll tell you, suppose we have this vector, so what, let's say it name as some xyz, what it will store, xyz of I x, what xyz of I will denote as, xyz of I denotes the minimum cost of minimum cost to go go to final cell, minimum cost to go to final cell from those cells whose value is I, right? So this vector xyz of I denotes that if all those denote the minimum cost to go to the final cell from those cells whose value is I, right? Means it is storing overall minimum distance of all those cells whose value is I. Now for suppose we are at any cell whose value is V, then we have to check all those cells whose values are less than equal to V, and then we'll taking that cell whose cost to go to final cell is minimum. But if we'll check all those cells whose value is less than equal to V, then it can take time big of 10 to the power 4. So what should we do to reduce this time complexity? So instead of checking all the cells whose value is less than equal to V in this vector, what we can do is we can make a prefix minimum from that vector. Now what is this prefix minimum denotes? So suppose we have prefix minimum of V. So prefix minimum of V will denote the minimum cost to go to the final cells of all those cells whose values are less than equal to V. Means all those cells whose are values are less than equal to V and the minimum cost of all those cells that will be storing prefix min, right? So when we have to find the minimum value, yeah, minimum cost of all those cells whose values are less than equal to V using this prefix min, we can do that in big O one time, right? I hope you get till now. And what are the three possibilities now? So suppose we are at some cell I comma j. So one thing is we can go to the right cell or we can go to the down cell. The third probability possibility is that we can and teleport to, suppose this value is V, so we can teleport to all those cells whose values are less than equal to V and their cost is minimum. and then at the end we will be taking minimum of overall minimum of all these three cases. So that will be our answer for this point, right? Now let's move to the code part. So if you'll see the code, then we have used two DP arrays to simulate the layer DP, and initially we have calculated the case of no teleportations. So in this case we are only allowed two movements, right movement and left movement, and we will be taking minimum of these two. We are taking minimum of right movement, we are taking moment minimum of left movement and storing that. Mhm. And after that what we do is we will be using layer DP, that is using the previous teleports that we have calculated to compute the future teleports. So we have used a loop from teleportation t is equal to 1 to t up to k, and then we have used the vector. So in this what we store is, for all cells whose value is v, in this vector we will store the minimum cost of all those cells whose value is v. So what best value of v denotes, what it will denote, it will denote the minimum cost to go to the final cell from all those cells whose value is v. So suppose there are 5 cells, yeah, we can say 2 cells whose value is suppose 5, their value is 5, but this cell takes cost to go to the final cell 2, and this takes suppose 4 cost to go to the final cell. So which one will be selecting, we will be selecting this one as it is taking minimum cost, and so best value of 5 will be storing 2. That is, once we reach to the uh, cell whose value is 5, then to reach to the final cell we will be taking value 2, right? Then using this best value vector we will be calculating prefix min of the whole what we call whole values, because when we do teleport, we can teleport to all those values whose value is less than equal to v. So we have to find that minimum cost in constant time, yeah, big of one time. So for that we'll be calculating prefix minimum. Once we calculated the prefix minimum, then what we can do is we move to the each cell, we, we move to the each cell, then check the right path, that what is the cost of the right movement, what is the cost of the down movement, and then what is the cost of the our teleportation movement, and then take minimum of all these three movements and then store that, and then we swap the previous dp with the current dp, and at the end we will return the answer, that is 0 comma 0. I hope this time I am able to explain you. So please make sure to like the video and subscribe the channel.